Hi guys, I noticed that not many people would finish their homework, so I feel like we need a refresher on the how to calculate the number of bonds. Excuse me. So I'm going to do a couple problems for you. You can scroll ahead if you want to see something different, or you can rewatch as many times as you need. All right, so the equation is here on the paper. The number of bonds is equal to the number in the octet. That makes everybody stable. What everybody wants is an octet to be stable, except for hydrogen wants two total. Group 2 only has 2 valence, so it wants 4, and group 3 only has 3, so it wants 6. Those 3 columns you might or probably won't need to do the math for. Towards the end, I'll show you which ones you absolutely wouldn't need the math for. So I'm going to just focus on columns, carbons group and up. So I'll start with O2, which I know we've done before, but maybe you need to rewatch it. So we have 2 oxygen. And so the first number is how many does oxygen need to be stable? The total needs to be 8. That's what I mean by number in the octet. The octet needs to be 8. And there's 2 oxygen. So we have to account for that. So we say 2 times 8. Each oxygen needs 8. And then the second number is the number of valence electrons available. And oxygen is in this group, so he has 6. But there are 2 oxygen, so both of them have 6 to share. Every time we do this, we're going to divide by 2 because every bond has 2 electrons, so that number will always be 2. It has nothing to do with the 2 oxygen. All right, 2 times 8 is 16, 2 times 6 is 12. That's 4 divided by 2, 2 bonds. So right away, that tells you you have 2 oxygen. The only thing you can do is a double bond because you don't have another oxygen to give another bond to. Now, how about the rest of the dots? This is where the octet comes into play, where you have to check to see you have a full octet. So you're going to count the bonds as 2. So the oxygen on the left has 2, 4 in his octet. He needs 6, 8. So he gets 2 more sets of valence electrons for a total of 2, 4, 6, 8 because of those 2 sets of unshared pairs. Same with the other side. They're identical. So you have 2, 4 in the bond, 6, 8. As I said in class many times, I don't care where you put the outer valence electrons. It's the electrons on the central atom that are going to change the shape. All right, let's do O3. So we have 3 oxygen now. Each of them need an octet. We have 3 oxygen. Each of them have 6 valence electrons. Always divide by 2, no matter what. 3 times 8 is 24. 3 times 6 is 18. Always divide by 2. 18, 19, 26. 3 bonds. So there's 3 oxygen now. So you can start out drawing this linear if you want, and then you'll have to decide whether it's going to stay linear. So we have 3 oxygen. The minimum would be a single bond, but this says 3 bonds. Excuse me. So we're going to need a double somewhere. We are showing 2 bonds, so either side can get a double bond. Okay, now we have our 3 bonds. We have 18 electrons to give out. On the right, we've already seen up above the double bonded oxygen likes to have 2 extra sets. So we'll go ahead and do that so that we'll have a total of 2, 4, 6, 8 for that guy. He's happy. Now the oxygen in the middle, oxygen in the middle has 3 bonds around him. So he only has 6, 2, 4, 6. So he's going to need another set. 8. That means we're going to wind up bending this molecule. The oxygen on the right only has a single bond, so only has 2. So he needs 4, 6, 8. All right, double check to see that we have 18 electrons. I'll do that in red, pink. So 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. That's how many we had to give out, and that's how many we have, and everybody has a full octet. And it really helped to start by knowing that we needed 3 bonds. All right, let's try something a little trickier. The carbonate polyatomic ion. So this has a charge, and so when you have a negative charge, it means add that number of valence electrons. Doesn't mean you can have 10 in an octet. It means you're going to need 2 extra valence electrons in order to get that octet. All right, so with the first number, the octet, I'm going to jot it down here. I always just do that. Carbon needs an octet. Oxygen needs an octet, but there are 3 oxygen. So 8 plus 3 times 8, or 8 times 4, same thing, is 32 for the first number. Now for the octet, carbon. If you look at the periodic table, carbon has 4. Oxygen, we know, has 6. So 4, but there are 3 oxygen. And this -2 means add 2 valence electrons. So 18, 19, 24. So the second number is 24. Always divide by 2. So 24, 8, 4 bonds. Oh, I never bent this molecule up here. It's going to wind up being bent. Because the unshared pair pushes those bonds down. Okay. And so, yeah, I'm thinking about the shape of this one. So if we, force of habit, we have carbon in the middle and we put 3 oxygen on it. It's only going to be this shape if there's an unshared pair on carbon, and we don't really know yet. Because if there's no unshared pair, then those oxygen will all spread out, and it'll be trigonal planar, 120 degrees. Okay, so we have 3 bonds so far. We need 4 bonds. So somebody gets a double bond. That's all that means. Any oxygen can have it. Doesn't matter where you put it. On any of those oxygen is correct. All right, so I see a double bonded. Well, let's look at carbon right away. We see 2, 4, 6, 8. He's got 8 in his octet. 2, 4, 6, 8. He isn't going to have an unshared pair. So we got to change the shape. We might as well do it right away. Because they're going to spread out. Okay, now we know that oxygen with a double bond has 2, 4, 6, 8. Oxygen with a single bond only has 2, 4, 6, 8. Oxygen on the bottom, single bond, 2, 4, 6, 8. Double check. We have 24 dots. Go pink. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 24 dots. That's our structure right there. All right, let's look at one with a hydrogen. Now, let's look at one you don't need to do the math. Don't do the math. If it's a simple single bond structure, something like CH4. Carbon has 4 valence electrons. It can't have more than 4 bonds. So right away, you know they have to have single bonds. Also, you have hydrogen involved. Hydrogen can't have more than a single bond because he only has 1 valence electron. Same goes for halogens, group 17. All the group 17 elements really only want 1 to become stable because they already have 7. So carbon, oops, I wanted to put a 4 there, sorry. I think I was thinking about diatomic chlorine. CCl4 is only going to have single bonds, because halogens already have 7, so when they share, they get 8. So halogens like single bonds. Just don't forget all those dots on the outside. else would you not need math? Like water? Oxygen goes in the middle, and hydrogen's on the outside, so he can only have single bonds. Oxygen has 6 valence electrons, 7, 8, when they share. Here's some math that you might need hydrogen for, but I won't give you this on a test. If you had HCN, we'll do the math for this guy. We know that carbon and nitrogen need 8 for an octet. Hydrogen only has 1 valence electron, so he'll only get 2 and become stable. Hydrogen behaves like helium, which only has 2 electrons, and he's still stable. So our octet here is a 16, 17, 18. And then valence electrons, 1 for hydrogen, 4 for carbon, 5 for nitrogen, 10. 2, 8 divided by 2, 4 bonds. Well, carbon goes in the middle. Hydrogen can only have a single, so the other 3 have to go with nitrogen. Check the octets. Carbon, 2, 4, 6, 8. He's already good. Hydrogen's good with a single bond. Nitrogen, 2, 4, 6, 7, 8. Full octet. We had 10 electrons to give out. Let's check them. Let's use yellow. 2, 4, 6, 8, 10 electrons given out. Done. All right. Hopefully this helps. And hopefully you can complete your homework. All right. See y'all tomorrow.